Hello all. So in this video, we'll be seeing about control systems and a topic relating to that. Translation mechanical systems. This is the topic that we'll be seeing today. And these are the concepts that you need to know before going to the topic. It is about mass, spring constant K, and dashpot B. And before going to the numericals, we'll see about what force voltage analogy is and what force current analogy is. So in force voltage analogy, force is equivalent to voltage and mass M to inductor L, spring constant K to capacitor 1 by C, capacitance 1 by C, and then dashpot B to resistance, displacement X to charge Q. And just like that for force current analogy, force F is equivalent to current I, then mass to C, K to 1 by L, B to 1 by R, and X to pi. So going to the numericals. For the mechanical system given below, draw its equivalent system and write its equivalent equations, and also develop force voltage and force current analogous circuits. So this is the mechanical system given for us. Now let's see how the equivalent system is drawn for it. As you can see in the previous image, we had two mass bodies M1 and M2, and there was two forces acting in between them, that is frictional force and then a spring present in between them. And at both the ends you had springs K1 and K2 also present, but because there are the both mass bodies are present on a wheel, there is no friction for the mass body and the ground. So there is no friction between the body and the ground. There's only a friction present between the bodies. So this is the equivalent system for it, where at displacement x1 you have the mass m1 and then the spring constant k1, and at displacement x2 you have m2 and spring constant k2. Because f12 and k12 are acting between the mass bodies, they are present between the displacements x1 and x2. And because the force is present only at mass m1, that is, it's directly acting on m1, and it's not directly acting on m2. So f of t is present uh, directly at m1 itself. So now let's see at the equation at node x1. F of t equals to m1 d square x1 by dt square plus k1 x1 plus k12 x12 minus x2 plus f12 d by dt x1 minus x2. And at node x2, 0 equals to m2 d square x2 by dt square plus k2 x2 plus k12 into x2 minus x1 plus f12 by into d of dt and d by dt of x2 minus x1. Over here, you can see at node x1, we have f2 equals to the equation, f of t equals to the equation because the force is directly acting on mass body m1. And at node x2, because the force is not directly acting on the mass body m2, it is 0 equal to the equation. And over here, you can see that k12 and f12 have x1 minus x2 and x2 minus x1 present over there, instead of having just a particular x1 or x2 alone. Because the force is present between two displacements, at node x1, it's going to be x1 minus x2. And at node x2, it's going to be x2 minus x1. So now let's go into the force voltage analogy equations. And then we'll derive the circuit, we'll construct a circuit for this equation. So force is equivalent to voltage. So it's converted to V of t. And mass is converted to inductance L1. And then capacitance to, no, spring constant to 1 by capacitance. And we derive this equation, and x is equivalent to charge q, so we replace x with q. And after replacing all this, we know that d square q by dt square is equals to di by dt. So we replace d square q by dt square with di1 by dt. And then q1 is equal to integration of I dt, I1 of dt. So here q1 is replaced with integration of I1 of dt. And just like that, we have replaced all the other charges, and then dq1 by dt also, because dq1 by dt is equals to I1. So we are replacing dq1 by dt with I1 and then dq2 by dt with I2. After replacing that, we go to the next equation of at node x2, and we do the same process where m2 is replaced with L2, and then again it goes on with the equation being 0 equal to L2 di2 by dt plus 1 by C2 integral of I2 dt plus 1 by C12 integral of I2 dt minus integral of I1 dt plus R12 into I2 minus I1. So after writing this equation, we know, seeing these equations, we can say that L1 di1 by dt and 1 by C1 integral of I1 dt and then R12, I1, R minus R12, I2. They're all kind of the voltage equations, voltage termed equations of inductance, capacitance, and resistance. So looking into that, we'll be constructing the circuit. So this will be the circuit. In this equation, we know that V of t is directly acting on L1 and C1, and then 1 by C12 and R12, they are present between both the currents. So we'll be drawing that in between. That is where they are acting in both currents itself. So here V of t is present directly at L12 and L1 and C1, and then L2 and C2 are present in the other loop, and the current in the loop 1 is I1 and current in loop 2 is I2, and R12 and C12 are present between the loops. So now going to Fi analogy. Fi analogy is same like the Fe analogy itself, but over here mass is equivalent to capacitance, and then spring constant K is equivalent to 1 by inductance. Over there it was mass was equivalent to 1 inductance, and then spring constant was equivalent to 1 by capacitance. And then over here resistance, that is friction, is equal to 1 by resistance. So after replacing all those things, we again derive the same formula. Over there you had replaced x with phi, I mean x with q. Over here you're replacing x with phi, that is magnetic flux. And then again deriving the formula with respect to that, d square phi 1 by dt square should be replaced with dv1 by dt. And then phi 1 is replaced with integral of v1 dt. And then d phi 1 by dt is replaced with v1, and then d phi 2 by dt is replaced with v2. Doing the same thing for the other equation also, we get it as 0 equals to c2 dv2 by dt plus 1 by l2 integral of v2 dt plus 1 by l12 integral of v2 dt minus integral of v1 dt plus r12 plus 1 by r12 into v2 minus v1. So after writing this equation, again comparing it all these equations with respect to current, we know that I of t is equal to, with respect to capacitance, it is C1 dv1 by dt, and then with respect to inductance, it is 1 by L1 integral of V1 dt. For resistance, it is I equals to V by R, so V1 by R12. And knowing that, we'll be constructing the circuits. As the question has only two voltages, we'll be having two nodes over there. I of t is directly acting on the node 1, V1. And then over there you have capacitance C1 and L1. At node V2, we have C2 and L2, and the R12 and L12 are acting in between the nodes. So this is how the force current analogous circuit, force voltage analogous circuit, and all the equivalent systems and equivalent equations are written. So this is all for this video. Thank you.